Well, good morning, good afternoon, everybody. Welcome in from across the continent. We've got so many students today, which is very, very exciting. And if you're new to us at Exploring by the Seat of Your Pants, we are all about bringing conservation, adventure, and science into classrooms around the world. And you're catching us on an epic day because today, in earnest, we begin for our 10th year in a row, our epic month celebrating and showcasing the most kick-ass women in STEM on planet Earth. We've got, I think, 50 broadcasts this month, everything from Egyptology to paleontology. We've got coral reef conservation. We've got a little bit of everything. It is such a wild ride, and you can check out all of it on our YouTube channel. I'm also really excited because we're diving into the speaker we've had on before. She's really fantastic, and she's going to talk to us today about a topic that seems to be insatiably interesting to all of you students around the world, which is Arctic exploration. So Eugenie Jacobsen is in Newfoundland with me here in our frozen island off the east coast of Canada. As I was saying to our students beforehand, I had to clean 3 feet off of snow off my roof. So I'm really glad to be back inside to do a little bit of a virtual tour with all of you. I want to highlight too, edmontonscience.org. We're going to be doing a bevy of broadcasts with them over the months to come. So lots of cool stuff to go if you're keen on more Arctic exploration. But without further ado, Eugenie, thank you so much for joining us today, and welcome to the broadcast again. How you doing?
I'm good. Thank you. I'm so excited to be here.
It is so exciting to get to feature this. You've got one of the biggest, we were talking before the broadcast, one of the biggest slide decks ever because you've got so much to share about your many expeditions up to Canada's north. So I'm going to zip it, turn it over to you, and I can't wait. Take us away.
Okay. Let me just pull up my slides.
Beautiful. Wants to work. Thinking about it.
There you go. Hang on. Okay.
We're waiting. We're good. We're set.
Okay, we're all ready. All right. Hi, everyone. I am so excited to be here. I was just thinking while I was watching that countdown that I would have loved to see something like this when I was your age. And so I'm really excited to be able to speak to you all today. So the talk that I wanted to bring you was a journey to the Arctic. So not just talking about how I ended up studying the Arctic, but also my path and how I got there. So before we start, like Jesse said, my name is Eugenie. I am a PhD student in marine science, which basically means that I've been in school for as long as I can remember. I feel like I'm a lifelong student at this point. I love to learn. I've always loved the Arctic. And so I'm just nearing the end of my PhD now. I'm also a science communicator. And so as much as I love learning about the ocean, I also love talking about the ocean. Jesse mentioned we have some classes from different places of the world. So this was before I knew, I think we have one group in Argentina, which is really exciting, but I didn't include you all on this map. But here are some places. So we have Canada, we have a few places in the States, and also Nicaragua joining us today. And so hopefully we can use this as sort of a basis to orient ourselves about where this story is going. Okay, so for this story, or where does my story start? I'm from a place called the Sunshine Coast, which is in British Columbia, which is on the west coast of Canada. And I put this little picture of me here when I was really little. I spent most of my time in the water, just in awe of it. And I think it started a lot of my love for the ocean after. So this is the Sunshine Coast. I know we're not at the Arctic yet, but just I wanted to highlight this. So this is where I grew up. There's a lot of deep fjords, big mountains, a lot of whales and seals. I was always really interested in learning about the environment. I also started doing kayak tours when I was a bit older. And so I got to take people out on the water and help teach them about what they were seeing. And from that, I got to see a lot of really cool changes that were happening in the water. And one of those changes was with these. I don't know if anyone wants to put in the chat what they think these jellyfish might be, and we can check later. But these jellyfish really started my passion for the ocean. They group together in these thing called smacks. So kind of like if you have a group of crows, that's called a murder, which seems really aggressive. But we also have this group of jellyfish that come together and they form a smack. And that helps with their reproduction. And so one of the things that I started to notice on the West Coast is that we were getting a lot more of these jellyfish smacks that were popping up in different places. And so that got me thinking a lot about science and about asking questions and about almost coming up with these hypotheses of what might be going on in the water. And another thing that I wanted to add is that I also at one point wanted to be a singer. This is me and my grandpa. I love to sing. There was maybe one dream that I had when I was a kid where I wanted to be on stage somewhere. But turns out I'm a good living room singer, not so much a stage singer. I also play piano, and I thought maybe my career path might have me doing maybe a little bit of music. But I just couldn't shake that thought of the jellyfish and sort of the questions that I had had about the ocean. And so from there, and I'm going to breeze through this quickly, and we're going to get to the Arctic here in a minute. I studied oceanography and biology, and specifically, I looked at sort of big things that were happening in the water. So this is again on the West Coast near Vancouver, and you can see that there's all these different changes of the water composition, like that the changes in color is what I'm trying to say. It's almost that weird turquoise color. And so my first research project when I was coming out of high school was about this very thing, and why are we seeing these changes? Just like I had thought about the jellyfish before, why are we seeing changes happening in the water, and what is causing that difference in color? And could there be maybe some threats on the marine mammals like seals and whales? So this was the start of my love for working on research vessels. This is probably one of the coolest vessels that I will ever work on, and that's including the one that we're going to talk about later. It is a hovercraft, and it can go both on land and on water. And using the hovercraft, we were able to go out and collect water samples of the water that was that turquoise color. And then we were able to use a microscope and actually look and find that the culprit of all of this was actually this really milky, almost like a chalk consistency plankton called a coccolithophore. And so that was very exciting because the process of having questions and then going out and testing it and coming back and saying, okay, well, that might be what's causing all of this coloration change was really a jumping board for me. But I wasn't done there. And so that was located in Vancouver. So again, on the West Coast. But I thought, okay, if I'm seeing these patterns that are happening with plankton, could I maybe see these patterns happening with fish or bigger jellyfish? And I also do love the cold, and I've always been fascinated by ice and polar regions like the Arctic and Antarctica. And I was wondering, if we're seeing these changes happening down south, are there other places like the Arctic that seem to be so untouched because we don't go there very often? Would those places then be affected? So, and this is where Jesse and I are. We are in Newfoundland, although I'm in St. John's, which is the town that's on the east side of this island of Newfoundland. And St. John's is really close to the Arctic. And so that's why we end up getting a lot of this snow, not so much in this picture. So we are the most easterly city in North America, actually. And then actually in one year, this is just a fun fact I put in 2020, we were in lockdown before the actual pandemic because of a lot of snow that we ended up getting, and the whole town was in a state of emergency. So we do have a lot of Arctic influence. And so when I moved here, and I want to bring this picture back, I started my master's at Memorial University in Newfoundland. And I had a project where I could study fish, and that is not a tongue in the fish's mouth. That is actually another fish. Sometimes when we collect the fish, they end up eating the other ones, and it's a bit of a problem, actually. So that was the project, was about studying fish, and specifically, it included a project where I could go north and finally go up to the Arctic that I had once dreamed about when I was thinking about jellyfish and plankton. And so now I was studying fish and the Arctic. And so it was sort of it's been a dream come true, and that's what I've been working on ever since. All right, so the Arctic. The Arctic is one of those places where some people, we don't go there, like I was saying, and some people maybe don't know exactly where it is. But essentially, it sits right on top of Canada and parts of Greenland, and also it goes all the way around sort of that circumpolar circle, which we're going to look at in a second. But here is the Arctic Ocean. But to get a better view of it, okay, that's a bit maybe too zoomed out. So we're going to zoom back in to planet Earth. Okay, that's a bit better. All right, so this, what we're looking at, you can see on the bottom is Greenland, and then that whole white thing in the center, that's an ice sheet that is within the Arctic Ocean. So that whole disk that we're looking at up there is the Arctic. And we can see that Canada has a lot of those archipelagos of islands. So all of those little islands that are dotted in the Arctic that tend to get ice covered. And so getting up to the Arctic is a bit challenging, which is why we need to use a vessel like the Amundsen, the icebreaker that I'm going to talk about. So there you go. That is where, generally speaking, the Arctic Ocean is. Okay, and why do we choose to study the Arctic? Well, first of all, because it's cool and it's awesome, and there's no place that quite feels as pristine, maybe Antarctica, but it feels very pristine, very untouched, and in a lot of ways, it feels like it's out of the reach of climate change and a lot of the changes from humans that we're seeing down south, but also we're realizing that that's not really the case, and that the Arctic Ocean is actually experiencing the impacts of climate change 4 times faster than the rest of the world. And a big reason for that is because of sea ice. So in the Arctic, if you have white sea ice and they're covering the ocean, but as the ocean and as temperatures start to warm and the ice starts to evaporate, it sort of shows that really deep color of the water, that black color of the water. And so it ends up absorbing a lot of the sun. Now, just to back up really quickly, it's kind of like if you were to go outside and you had a white t-shirt on and it's a warm summer's day and you're a white t-shirt and you're okay, but your friend shows up with a black t-shirt on a summer's day and they get a lot more hot than you do. And so that's what's happening, is that the ice actually helps to reflect a lot of the warmth. But now that the ice is less, then it gets a lot warmer. And that has a lot of impacts for the animals that live there, like the polar bears who now don't have as much sea ice. Of course, also for the seals that polar bears feed on and for seals to find food. And then also there have been indigenous peoples that have lived in the Arctic for millennia. And so the Inuit have used the land for food sources, for their housing. But with all of these changes, it's causing these effects on how they live their day-to-day life. And so we know a lot about what's going on maybe over the water. We can see these changes that are happening, but what's actually happening under the ice, because those are things that we don't see. And knowing, for example, how many fish are in the ocean is something that we'll never really be able to answer. But can we get a little bit closer, and what does that look like and how do we do it? So this is where the Amundsen part comes in. So this is a ship that I work on every summer. I've done 6 expeditions on this ship over the last 5 years. I've been lucky enough to go. The trips themselves, you go for a month at sea. So imagine, I don't know if there's anyone that thinks that they could do like 5 months or a month at sea, let me know, because sometimes it can get a little bit long. I can only go for a month, otherwise I feel like I get too cold. But this is the Amundsen. It's an icebreaker, and it's based in Canada, and then it travels up and does all of its expeditions in the summer. And this is something that I wanted to show. This is a time lapse of the Amundsen going through the ice. And we can see how it tries to navigate all the different ice flows, and how if we weren't in an icebreaker, this would be a lot more challenging, because you just wouldn't be able to get there. And there's this point in the video also where you can see that the ship stops, and it's not because the video stopped, but it's because someone, I think in the bridge, was making a call to one of the engineers that's in the engine room and said, hey, can you put the other engines on? So there's actually 3 engines or motors, I guess, that they have on this ship. So they need an extra oomph to get over the ice, because this was one time where I thought we were going to get stuck, but we didn't, of course. It's okay. So, and this is one way that we travel to all of these different stations that normally we wouldn't have been able to before. It's almost, oh, see there, it got stuck again. Oh, it's so very satisfying to look at that one. Okay. All right, so on the ship, there's about 80 of us that are there. Everyone has a role or a job that they're doing. So there's 40 scientists that are there, and there's 40 Coast Guard crew members. So there's missing a lot of people in this picture here. But just to say that there are navigation officers that help us with the ice. There are sea ice specialists. There are people that study birds and whales. There are people that study pollution in the air. There are people like myself that do more of the biology. We do the fish and the plankton. There are the captain of the vessel as well. There's even a nurse on board. There's the cooks. There's everybody that works together to make this a successful research mission. So let's pivot now and talk about fish and zooplankton and the things that I work on the ship that are very near and dear to my heart. So this is something I wanted to try, Jesse. Hopefully this works, but the zooplankton, I just want to know if anyone knows what this is or what they think zooplankton means, because we talked about plankton, but what is zooplankton?
So we've got a bunch of teachers here on StreamYard with us, Ms. Gonzalez, Ms. Coburn, Mr. Gerard's class. If you guys want to chime in the chat, YouTubers, you guys have been really on the ball for answering some things. So zooplankton, and by the way, this is a really niche thing, but almost everyone pronounces it zooplankton, and I'm in the zoo camp, so thank you very much for joining me, because it should be zoo, because it's spelled like zoo, and together we're going to fight off all the people who think otherwise. Let's see. Plankton, by the way, in general. So we've got, for anyone who wants to chime in with that, we've got things floating around in the water, maybe small animals in the water. These are all really good answers to begin, actually. So is there anything you want to elaborate on that? Maybe small animals or small things floating, Eugenie?
Yeah. So, okay. So we are going to, so zoo, meaning we can think of like zoo animals. We think of animals in a zoo. So the zoo part means animal. And then the plankton part means a drifter. So the word actually means like a drifting animal, which I think is pretty cool. Okay, so the way that we sample, so we go in and we take a little sample of the plankton and the fish that are there. We use nets to do that. We put them in the water for about 10 minutes, and then we can get a catch that looks like this. So in this case, those top two pink ones are krill. We also have some amphipods that are kind of like these insects. We also catch a little bit of juvenile small fish and other sorts of plankton. And then this is one that I love a lot. It's called a hystrix. And to me, it just kind of looks like an alien organism in there that I think is cool. We also look at sort of the fish communities that we find. So what kind of fish are there and why are they there? Some of the questions that we're asking ourselves. So we'll put our net down and then we'll sort all of the different catches. In this case, we can see there was a lot of shrimps in this one place. There were maybe some anemones. And the one that I was holding there is an Arctic cod. And so with all of this, we can also use other projects to say, okay, maybe like what kind of things are they eating? We can look at their diet, their stomach. So there's a lot of people that rely on the samples that we collect when we go up north. This is one of my favorite fish. This fish actually has an antifreeze protein, and it looks like a chicken breast, I find, and it can survive in very cold waters because of the antifreeze properties of it. And it also always just has a really round belly, and I just love it. So this is called a snailfish. We also have lumpfish that we catch a lot. This one is also very cute. This one actually had some little crab larvae on it, I just noticed. These lump suckers are also very cute. That one is maybe only like an inch. So all of these are fish that we've collected up north. This is Arctic cod. This is one of the biggest fish that lives in the Arctic. And it's really not that big because that's my hand. And it just goes to show how small the species are when there's not a lot of food for them to eat. And so the Arctic is, again, really vulnerable because they've maximized how much they can eat to survive, sort of thing. So that is Arctic cod. This one's really cool. This one's a basket star. So it's a sea star with these really long appendages that it can snatch food out of the water and create habitat for other small fish. This is a really cool discovery that we had this past year of jellyfish that we saw. It's a ctenophore. It's another one of those zooplankton ones. It drifts in the water. Very fuzzy, and we still haven't identified it, but we think it might be a new species. This one's really weird. It's called an abyssal grenadier, meaning that it lives in the abyss in the deep ocean. It also looks like a rat. It's also known as a rat tail. And then these two, which were found more down south as they're much bigger, but these are called eel pouts, which I also really liked. So what I wanted to say is that the Arctic is very colorful. And so when we look underneath the ice, these are some of the species that we could find. All right, now what about what's on the seafloor? And what are some ways that we find what's actually on the seafloor? So one of those, we use these things called baited cameras. So there's at the very top of that frame, there's a little camera, and then we set the camera out into the water and we leave it there for the whole day, and we come back and we look at the footage. And sometimes when we look at the footage, we can actually find things called Greenland sharks, which are these big, long sleeper sharks that can live for up to 500 years. So they move really, really slowly. And I wanted to show you just some of the ones that we've caught here. Wow, they're huge.
I love them. They're just the most magnificent deep sea creature. They're fantastic.
They're very cool. And scientists can actually age them by looking at how many parasites they have in their eyeballs, which is very cool, and how many marks that they have on their skin. So there you go. There's a Greenland shark. That was a very exciting day when we saw the Greenland sharks there, and it's rubbing up on the squid bait that we put down for them. All right. What about submarines? Do we have those? We do have something on the Amundsen called a remotely operated vehicle, and it has two arms you can see on the front that pilots can actually maneuver from inside of the ship. And it's sort of like a tool to go collect really specific samples. So what we have are a panel of scientists and 4 pilots that sit in a room with, I don't know, like 200 monitors. It seems like, no, not that many, but a lot of monitors. And they can sit there and say, we want this thing, this thing, this thing. And they go and collect it and come back and analyze it. These are just some images that I loved from the Amundsen. This is one image that when a benthic person, so someone that studies the seafloor, looks at this image, they might say, wow, look at all the corals and look at all of the sponges. Whereas I just see the 2 little fish in the corner, the little wolf eels in the cage. So everyone sees the things that sort of resonate with them. And I always love to think about that. They also do some mud sampling, water sampling. I added this in later, but I think we're getting a little bit close to time. There's something called a rosette, and all these different bottles that collect water at different depths. And that helps us a lot to understand how water has moved and is moving with climate change. And this is just one of the ways that they collect the water. And then all of the scientists come in and take all of the water from those samples that they need. And so again, it could be like 40 people could be using this one instrument to collect their samples. With glaciers as well, there's a lot of work that is happening on the ship with glaciers. This was last year. We got to go out on one of the small vessels that comes apart from the big ship. So this is going along Belcher Glacier, and we were mapping how far the glacier was shrinking because they had been there the years prior. And of course, while we were there, we also got to see a polar bear in the water. So nice. So what we're doing with all of this information is that we're putting all of the pieces together to create a story. So again, all of those 80 people are working together to better understand all of the threats that the Arctic is facing, who are the players in the game, and then ultimately we're trying to have a complete picture of what the Arctic looks like, and what are the ecosystems present. I don't think I'll have time to play this video. I hope it doesn't play. But what I wanted to say...
You've got time, Eugenie. If you want to play the video, you're welcome to.
It's a bit of a long video, but I just wanted to
Okay.
really say this last message. I just feel was really important. I was trying to think of the takeaways, and we've talked a lot about the Arctic, but the things that I really want to say was to be curious and to dream often and to be you. So I wanted to bring those 3 early pictures of little Eugenie back. Originally, I had a dream that I wanted to be a singer on a stage, and then now I feel like I am living my dream, doing something completely different. And a lot of that is attributed to following my curiosity and allowing my dream to change and trying a lot of new things and gaining a lot of skills, because you can be so creative in science as well. I don't do music every day now, but there's a lot of different ways that we can be creative. And it takes a lot when you think of new projects, for example, of how can we all work together. So with all of the talks, I think that will happen this month, and whether the classes will come back for those, I just want to encourage everybody to be curious and ask questions, and to always allow yourself to change your mind and change ideas. And so yeah, that's it. Should I go back and play the video?
If you have some time, so if you'd like to play it, by all means, we'd be curious to see it, and then it'll give our classes time to get ready with some additional questions. So classes, put your thinking caps on. YouTubers, you can share them there, and if you want to share with us, we'd love to see it.
Okay, so the video was a video that I had made last year it was just shared with the people that were on the ship. It was just like almost like a diary of all of us together, and to say thank you to the Coast Guard crew that had been with us. And also it shows some of the images that we got from the ROV, that submersible. So I'm just gonna play this.
Who's hot, who not? Tell me who rock, who sell out in the stores. You tell me who flop, who cop the blue drop, who jewels got blocked. Who know if you don't get down to the blue drop. The same old pimp, mace, you know ain't nothing changed but my limp. Can't stop till I see my name on the blimp. Guarantee a million sales gonna double up. You don't believe I'm gonna run, double up. We don't play around, it's a bet, lay it down. They didn't know me 91, but they know me now. I'm the young Harlem with the Goldie sound. Can't hold me, hold me down, cooler. School me to the game, now I know my duty. Stay humble, stay low, blow like Woody. True pimp, spin no dough on the booty.
What they want from me is like the more money we come across, the more problems we see. I don't know what they want from me is like the more money we come across, the more problems we see.
I know you rather see me die than see me fly. I call all the shots, rip all the spots, rock all the rocks, cop all the drops. I know you think I'm down when all the ball stops. You never home, gotta call me in the yacht. 10 years from now, we'll still be on top. Yo, I thought I told you that we won't stop. Now, what you gonna do with a crew that got money much longer than yours? Get a team much stronger than yours. Violate me, this will be your day. We don't play, mess around. Be on your way, cause it ain't enough time here. Ain't enough time here for you to shine here. Deal with many women, but the treat down fair. And I'm bigger than a city like that in Times Square. Yeah.
I don't know what they want from me. It's like the more money we come across, the more problems we see. I don't know what they want from me. It's like the more money we come across, the more problems we see.
B.I.G.P.O. P.P.A. No info for the DEA. Federal agents mad cause I'm flagrant. Tap myself and my phone in the basement. My team supreme, stay clean. Triple B, miracle dream. I be that. Catch a seat at all events been. Send hostess, girls on shoulders, play for it. I told you, be a mic to me. Lose too much, I lose too much. Step on stage, the girls do too much. I guess it's cause the man do too much. He lose my touch, never that. If I did, ain't no problem to get the where the true players at. Throw your rollies in the sky, waving side to side, keep your hands high. When I give your girl an eye, play it please, lyrically, you can see B.I.G.B. flossing, jig on the cover of Fortune, 500. Phone number to man, I got the know, I got the dough, put the flow down, piss at, black and plus, like this at, dangerous, on Trizac, DJ ass, Trizac.
I know what they want from me is like the more money we come across, the more problems we see. I know what they want from me is like the more money we come across, the more problems we see.
It's a riot. You highlighted in that video something that I want to impress upon all our students, and this is true of Arctic voyages, Antarctic, deep sea space, whatever. I think the assumption when I was a kid is that it would be a bunch of serious people of science, and it's actually a bunch of nerds in a perpetual dance party. That is basically all expedition work on Earth. So thank you for highlighting that. Oh, it's a riot. I'm going to start off with a question we got online, and we get this every time these are featured, and then we're going to head to our Notre Dame High School folks for our first question live. In the video, you have 2 green laser beams. What is the deal with the 2 green laser beams? Because I love highlighting this.
Oh, that's a great question. So that helps us with scale. So those are 10 centimeters apart. So it allows us to see, okay, if that's 10 centimeters, then how long could this Greenland shark be? So it's to help us with scale.
It's like if you go outside and you take a picture of a mountain, it's very hard to know how big something is. Or, oh, there's a caribou over there. What's the deal? And it's just such a fantastic little tool. I love it. It's so easy and something that you can add to pretty much any expedition underwater. So very neat. Thanks, Eugenie. If you want to come out of screen share too, so you can see us again, have a bit of a conversation, whatever your setup is, we're going to head to Mr. Gerard's class. Come on in and take us away with our first live question. Hey. Hi.
Say, I'm Sophie, and you can just ask first.
Oh, okay. My name is Sophie, and my question is, what were some of the keystone species you found in the Arctic?
Ooh, cool question.
Oh, that's a really good question. And I like that you use the word keystone species. So the one that I showed you that was in my hand, it had my blue glove on, that is one of the keystone species because Arctic cod is sort of like the powerhouse of the Arctic because everything seems like most of the animals eat it or rely on it in some way. So it actually has something that's called, a new term is called wasp waist, which basically means that it's sort of like this pinch point. And I guess, then that would be like, it's considered a keystone species because of that. So Arctic cod is very important in sort of with the shuttling energy in the Arctic.
Yeah, fantastic. What a neat question. Thanks, Sophie. Miss Coburn's class, our Dalewood School, come on in and take us away. Hey.
Hi, everybody. First of all, the amount of jobs that you told us that are possible are unbelievable. So you just blown us away by that. We're a remote class, and I have Alexis at home, and she's going to ask you a question.
Perfect. Hey, Alexis.
My question is, what is your favorite discovery so far as a marine scientist?
Ooh, no pressure. Favorite discovery so far?
Actually, I just discovered something last week that I'm really excited about. And normally it doesn't happen because actually I'm an ecologist, which means I try to make sense of what's in nature. So we don't often do like these experiments and we don't have the chance to discover something. But for one of my projects of my PhD, I'm studying whether jellyfish are taking over the Arctic. And I maybe wanted to talk about that today, but I thought it might be a bit too much. And so I wanted to see if jellyfish were in the diets of fish. So whether fish were eating jellyfish. And I did that by using a lot of these genetics tools. And I actually found that jellyfish are being eaten by fish, which is really cool to me. And I'm really excited about it because it does mean that they're becoming a lot more present in the Arctic, and it can change sort of all of the energy from like the little guys all the way up into the big guys like the polar bears, and the little guys meaning the fish. So I'm really excited about that.
Speaking of jellies, by the way, at the very beginning of your talk, you had a jelly thing and you asked a question about it. And I'm pretty sure our Newfoundland classroom got this right. It is a moon jellyfish, right?
Yes, it is. Yeah.
Very common in aquaria. So for our classes that might have ever had a chance to go to Ripley's Aquarium in Toronto, has tons of moon jellyfish. They're really, really common there. They're really special and beautiful species. So great job and cool question, guys. All right. That was the exact same question we had from our YouTube audience about your favorite discovery. So we're going to actually head back to Notre Dame High School. If you guys have another one for us, come on in. Hey. No rush. You're good. Take your time.
Question here.
My name's Bella, and I was wondering how the Greenland sharks are able to live for so long if there's very little nutrients or resources.
Yes, great question, Bella. We've actually never had that one ever in our history, so do tell.
Yeah, so Greenland sharks, I think there's a lot of debate about this because we really don't know that much about them. They're not commercially valuable, and anytime you have a species that doesn't have a lot of commercial importance, like with people eating them and things, they don't get that much studying. But what we do think is happening is that they reserve a lot of their energy, for one, because they're so slow moving, slow. They have really slow growth rates, so everything is very slow, kind of like you would have a sloth, like really not expending much energy. And the other thing is that they're scavengers, meaning that they eat what sort of settles onto the seafloor, and they're not aggressive. So they're almost like these passive feeders in a way, which sort of seems like it makes sense, because the same thing with whales that are baleen whales that feed off of krill and things. I mean, baleen whales are huge, and so it's sort of that same principle. They're just they just know what they're doing, I guess. Yeah, and really slow metabolism.
I'm going to pass along some resources on some cool Greenland shark stuff. So, Bella, if you're keen, Natural World Facts is an amazing YouTube channel. Blue Planet 2's done some stuff on them, like they're really, really special creatures. But that is super cool. And you touched upon something which is kind of neat, and you and your answer as well. Like a lot of things in the very bottom of the ocean are huge. We've got giant crabs, we've got giant sharks, we've got really big marine invertebrates like isopods, like a woodlouse. And it's really, really interesting because most of the energy that comes down there comes from things that die and then fall to the bottom. So you end up with these weird big feeding frenzies on the seafloor, which is easily one of the coolest things in all of nature. So great.
I think
question.
it's called, and in the Arctic and actually in Antarctica, they do have big species too, and in the deep sea, and it's like polar gigantism or something.
Yeah, it's
Something
so
like that?
cool.
Yeah.
We've done whole programs on Antarctic creatures under the water and how giant they are, like sea crabs or sea spiders that are like 3 feet across, and it's just
the colossal squid too, right?
Yes, I know. Yeah. This is half the fun. All right, I'm going to take a quick one from our YouTube friends, and then we'll head back to our live groups. Eugenie, is there a favorite part of your job? Is there something that gets you up in the morning every day? No pressure again.
Oh, I love being out at sea. I think that for me, being out at sea is where it started. And so being able to go back is always such a privilege. And it never is lost on me when we're up north of how much of a privilege it is. So I would say being out at sea is my favorite, because then you can just let your curiosity like run rampant. And the project that I had that I talked about, where I discovered that fish were eating jellyfish in the Arctic, that was a project idea that I had when I was up north. So the best thinking happens when you're out there. It feels like you're a true scientist, and also the people are really what makes being out there amazing, because the people, we're all like, everyone is like-minded and is so curious, and everyone has all of these stories and all of these skills that they come with. And so getting to know people also in the field is one of my favorite things.
It's really interesting. No matter what type of person that we bring on the broadcast, everyone says field work, whether it's being on a ship or in East Africa or in Australia. Like, get out on an expedition at some point in your life. You don't need to do it for a career. If you get a one-off opportunity to do this as one of the roles that Eugenie has mentioned, it really does change your life and makes you think of the world in a different way. So check out AmazonScience.org if you're keen. Maybe there's some potential for some of our students in the not too distant future there, but lots of really, really cool opportunities, and I love that answer. We're going to take 3 more questions together because time flies and you're having fun. So Miss Gonzalez's class, welcome in. I know Miss Gonzalez herself couldn't come in today, so thanks for doing this as a sub. You guys rock. They want to know, what's the biggest thing you've seen underwater? And this could be with an ROV. This can be personally. What are some giant creatures of the deep? Or is it the Greenland shark?
The Greenland shark would be the biggest one, I would say. I will preface this. I did go to Antarctica a few years ago to look for the colossal squid. So had I found the colossal squid, that would have been my answer. But my other answer is orcas, because coming from the west coast of Canada, we have a lot of orcas. And there was 2 summers ago, I was snorkeling. I was with my dog, and all of a sudden we heard these orcas not far away, and they were probably about 20 feet away. They were too close for my liking, I think, but that was probably the biggest thing that I've ever encountered underwater.
Very cool. We've got a few coastal classes today. We got some folks in Newfoundland, some folks in California. Like, if you get whale watching, it really is like one of the great joys of all time. It no amount of video or pictures can do justice to a whale in person. So I'm so glad you mentioned that. We're going to head to Miss Coburn, and then we're going to wrap up with our high school crew with one final question. And I want to stress for anyone who's keen after this, Eugenie, you didn't want to harp on this too much, but you have a fantastic TikTok channel where you do all sorts of really, really amazing and stellar videos. So I encourage our classes to check that out, as well as that Amundsen Science website, because there's lots to discover there. But Dale Wood, come on in for one more question and take us away.
Yeah, we've got John here from our remote classes, grade 7. He has a quick question for you.
Perfect. Hey, John. John's thinking about it.
He's thinking about it. Are you there, John? Oh, there we go.
Hello?
Yep.
How are changes in Arctic sea ice affecting marine food webs?
Ooh, did you catch that?
How are
changes in marine sea ice changes in the Arctic sea ice affecting marine food webs? Cool question.
Whoa.
Yeah.
That was my master's project right there. That's a really good question. Very well thought out. They are affecting it in a lot of ways. I mean, if we already talked about Arctic cod, that one fish that they, one of their larval stages, they are, how do I say this? They're more associated with the ice when they're younger. So they spend a lot of time feeding in the sea ice, and it's almost like a little nursery for them. So those ones, the species that are more endemic, what's called, to the Arctic, those ones, or the residents that rely on the sea ice, those ones are the ones that are getting more affected. But one of the things in my master's that I thought was really cool, what I was learning about, is sea ice. With the loss of sea ice, it's causing there to be more food web activity happening in the open ocean. And that's because a lot of the particles that come from the atmosphere and then all of the plankton, it ends up getting recirculated. But when you have more of a sea ice dominated ecosystem, it means that all of that heavy sea ice sinks to the sea floor. So it means that your organic matter sinks. Now, this is kind of going over, I think, what this talk, I'm really surprised by this question. But basically, it just means that you have two very different ecosystems that are coming out of the loss of sea ice. So one, you have more what's called remineralization in your open ocean, versus now you have less dependencies on the benthic, which is your bottom. So there's a lot of changes that are happening to the energy. It just means that now more energy is recirculating, like I said, in the open ocean with the phytoplankton, as opposed to the heavier plankton at depths.
Yeah.
That was a hard one.
That's a really good, quick answer for a very challenging question. So thank you, John. We're going to have to do a whole other broadcast on that just for you in the future. Yeah. But we're going to wrap up with one final question from our high school crew. Thank you guys so much, Ms. Gerard, and take us away to wrap us up.
Yeah, so we had a question about Eugenie, since you said you've traveled and gotten to do this research over many years. Like, what are your biggest takeaways and what you've seen, especially with climate change happening in the Arctic?
Amazing.
Great question. One of my big takeaways is last year we traveled to 82 point something degrees north. So we traveled to it's called the Lincoln Sea. It's above it's the north of Greenland, and that was the first time that a Coast Guard vessel of that class in Canada had ever traveled that far. And it was the first time that the Amundsen had ever traveled that far. So we celebrated and we thought it was great, but there was also this underlying tone of it that felt kind of very ominous, because the only reason that we could get there was because there's been less sea ice, and so there's more of a passage. So I would say my biggest takeaway is that even in the last 4 years, I can see that there's less sea ice around. And even the fact that when I first started my graduate program, we couldn't get that far, and then now in the last few years, we've been able to travel to the Lincoln Sea, which the Lincoln Sea is really unique because it's the last place where there's this multi-year sea ice. And so it's the last place where there's sea ice that lives throughout entire years. So it could be like 3-year-old sea ice. So that was I would say that one was the big takeaway. And also the work that we do with the Indigenous communities and how it's tied in, everything that we do ties into their livelihood and their food security and their housing, and how we can better collaborate and really have them tell us of the research that they're interested in being part of. And so really taking that collaborative approach to all of our research. And so we work together to tackle some of these big issues.
Thank you so much for that. And it's a great question. And it's one that, we don't even need to have people that are Arctic experts to come on and talk to about the difference in climate change. Talk to your teachers, talk to your parents. Over the last 20 years, the weather is radically different around the world. And it sort of underscores why we're doing so much to try and combat that. And there's a lot of great work being done, even in places you might not expect. So I'm really glad we wrapped up with that. I want to stress again, AmazonScience.org, your spectacular TikTok channel. A huge thank you to all our classes joining us from Ontario, California, Newfoundland, Nicaragua, Argentina, and beyond today. So I'm going to bring in Miss Gerard, Miss Coburn. I know everyone's leaving right now, but that's okay. Have a wonderful day, everyone. We'll see y'all soon. Thank you so much, everyone. And